In 4.2, we're going to be learning about the greatest common factor. A common factor is a whole number that is a factor of two or more non-zero whole numbers. The greatest common factor is the largest factor that those numbers have in common. In the first example, it talks about a choir director who wants to divide the choir into smaller groups. There are 24 sopranos, 60 altos, and 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can be formed? How many sopranos, altos, and tenors will be in each group? The greatest number of groups that can be formed is given by the GCF, the greatest common factor of 24, 60, and 36. You can use one of two methods to find the GCF. Method 1 is where you list the factors. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Remember to use your divisibility rules. Factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. When we look at these lists, we can find the factors that all three numbers have in common. The common factors are 1, 2, 3, 4, 6, and 12. Out of that list, the largest one is 12. So the GCF, the greatest common factor of 24, 60, and 36, are 12. The other method of finding the GCF is to use the prime factorization of each number using factor trees. The GCF is the product of the prime numbers that they have in common. When we factor out 24, I do 4 times 6, and I continue to factor that out to its prime factors. So the prime factors of 24 are 2 times 2 times 2 times 3. When I factor out 60, I get the prime factors of 2 times 2 times 3 times 5. And when I'm factoring out 36, I get 2 times 2 times 3 times 3. Remember to always list your prime factors in numerical order from smallest to largest. But when I'm using the prime factorization to find GCF, I do not use exponents. Looking at the list of the prime factorizations, the common prime factors, they all have a 2 in common. So I write that here. There's another set of 2's in common. So I write that down again. They also have a set of 3's in common. In order for it to be a common prime factor, all three numbers have to have it. And because the GCF is the product of the prime number, we multiply them. So when I multiply 2 times 2 times 3, I get 12. And that is another way to find the GCF using prime factorization. Right now, I would like for you to find the greatest common factor using one of those methods that I just discussed with you to find the GCF of 16, 32, and 40. Press pause on the video while you're solving, and when you're done, press play to continue with the rest of the notes. The next concept in this lesson deals with numbers that are relatively prime. Numbers are relatively prime if their greatest common factor is 1. That means that those numbers have no other factor in common other than 1. So in example 2, I gave you the numbers 35 and 54. The factors of 35 are 5 and 7. The factors of 54 are 2 times 3 times 3 times 3. When I look at these lists, there are no common factors other than 1. They have nothing in common. Since 1 is their only common factor, these numbers are relatively prime. Please complete the checkpoint to tell me whether or not 18 and 33 are relatively prime. Find their GCF. We can also find the GCF of monomials. We're going to factor out the monomials just like we did in lesson 1. If I have 18xy squared, the factors of that are 2 times 3 times 3 times x times y times y. When I factor out 28x squared y squared, I get 2 times 2 times 7 times x times x times y times y. Let's circle the factors that they have in common. They have a set of 2's in common. So I'm going to write that number over here. There are no other 2's that they both have in common. There's a 2 here, but not here. That is not a common prime factor. They do not both have a set of 3's. Now let's move on to the variables. They both have an x. So I'm going to list that. There is not another pair of x's that they have in common, but they do have a pair of y's. And they have another pair of y's. I list them both separately. And again, finding the GCF using prime factorization is the product of. So we multiply them. The GCF of these two monomials would be 2xy squared. For the last part of this worksheet, you're going to complete checkpoint number 3 to find the GCF of those two monomials that are listed. See you in class.